So what we want to look at is trying to import data from the web directly into R, your workspace. So at the advanced level, maybe later you may be interested in, you may be doing web scraping. You have some data on the website and you want to bring it into R to use. Take Wikipedia, for example. You can take data from there and format it for use. But you may also have an Excel or a TXT file which is sitting on a website. Provided it's a freely accessible website, you can always bring the data into R for use. Also, there are some packages which get data from specific websites, and they are usually maybe stock data or stock market data or financial market data. We'll look at that one. So let me add that on here. There's a particular package called Quant Mode, which you can use to get data from financial markets directly and plot them. I'll add that. It's not in the code now, but as we go along, I'll add it. Look at what we want to do. I want to show you two data sources that I'm going to use. Can you see the web page?
Yes.
Okay, good. So some time ago, this was which so I think so 6 years ago, I did some web scraping with and used that for heat map of the population distribution of Ghana across the different regions at the time. So we are not doing that. It's only data that I want to show you. So there's the link. If you look at this, it is possible that if you have the data from any website which is stored in typical HTML format, you can extract it and clean it up for you as for what purpose that you wanted. So what I did was I loaded this data and I formatted it to generate heat maps. I showed you. If you go to my GitHub page, you will see that the files are there. You can pick them up later if you need to use it in some format. There are a lot of codes I have to format and put them there, but you can pick this one up and see. So we'll try and load that data and see how you may format it and use. The next one is that we are in a particular season. I hope you are in the Olympics. So in today's example, we are using quite a number of Olympic data. So there's this data for the Olympic Games. Here you see the games from when they started across the countries. So we also extract the data and see, even though we are not going to work with, we are not going to analyze all this data. If you are online, you can, if the data is online, you can always extract them or import them and format for use. These three packages will help us do that for the website. You realize that I have separated the codes into different parts. So installing from importing data from the web. So remember there was read.csv, there was read.table. If you are reading from text file, if you are reading from CSV, it's read from CSV. If you are extracting from or importing from the web, it's read_html. And it's coming from the rvest and stringer packages. I think you are seeing the RStudio now. So we are using these three packages. So I'm using these packages. Okay. So as always, we will load random. And this is the website that I showed you just briefly. So I mentioned that we have used the read.txt. We have also used the read.csv. For importing data from a web, we are going to use read_html. That is from the rvest, XML, and the stringer packages. So we can load the data, import the data, and we can look at the structure of the data. And you can see that it is an XML document in XML columns. So this is basically the columns and this is the data. We can confirm what the class of the object gh_pop is XML. Now, if you come here briefly, let's go into the page again. So if you look at this, page, how many tables do you see on this page? Not columns, tables. All the way to the end. That's right, that's one table. But if you look at this, let's go from the top. So let's see how many tables we have. One. We have two here. We have three. We have four. So you have a lot of tables.
Yeah.
Yes. So whenever you are on a page that you want to scrape data from, you can check the number of tables on the page, which you will know with this code. So the nodes will be the table. So if you look at this, the HTML_nodes, and if you specify table, it will give you the number of tables in the data you have imported or on the page. So that gives us, this is an indication that we have just one table. And that means we can work with only one table. So if you want to specify that specific table and we use the HTML_table. And obviously there's a header that we need to work with. So header true. And we are going to fill the table with all the data that is there. And here is where you choose which table to use. So we saw that we have only one table. So if we use two, for example, we should have an error. And it says subscript out of bounds. There's no more than one table, so we cannot use that. We need to go back to just one table. And that works fine. And we can look at the structure of that. So realize that we have a table of 19 rows and 9 columns. And it's of class table and or data frame. So with this, you can now start to work with the data in the way that you want. So that's for that page. Now let's look at the Olympic Games website that I showed you, where we saw that there were a number of tables. I will count all of them for us here. So we read this one, that works fine. And again, it's still an XML. We can just, for the sake of completeness, indicate the class. Okay. And then we may want to know the number of tables that are in there. So how many tables are there? There are 55 tables here, which means we can pick any of the 55 tables and use. So 1 through 55 should be fine. So we can choose any of them. So you choose 5 and the structure of that. Since it's also a data frame, we can even look at it as a table, and this is it. This is table 5. Now we can look at the dimension. So for this particular table, there's 10 rows and 16 columns. If we check, let's look at the last one, which was 55. That's just 4 rows, 2 columns. There was a very large table. Which one was it? I think it was maybe table 3, I think. there's 74 rows and 4 columns. Okay. So we will be working with the Olympic data. So briefly, we can set our working directory, and we may want to write this file into CSV so that we can use it in the future. So we are on table 3, so maybe we can write table 3 and see how that works. So the code is write.csv. Okay. And so this is how it works. You write .csv, then the object and the file name with extension. Okay. In quotation. So if you do that, you can have your data saved in your working directory. So that's a comment. Now let's write it as well. So as it stands now, it's only 2. So only 2 is the object. Then we are going to give it a file name, quotation. First of all, it's going to CSV, so we can keep that one there, and we give it a name. So maybe only 2, and that should be fine. Okay, cannot coerce to a data frame. Okay, that's fine. Just a moment. Make only as a data frame. If that does not work, we'll do that to another one later. Only 2. Okay, so now we have now changed that one. I was going to do it later, but we have now saved that as a data frame. Then we can write it. So it's no longer only. It is ly, and that one can be saved into a data frame. Can be saved into a CSV. And this CSV is now sitting on your desk in your working directory. So if we go into our working directory, for example, we just save the file as L-2. Yeah. Okay, so you realize that we have moved the file, that web space, that HTML data, into a CSV on our desktop. And from there, we can use it in a way that we want it. Okay. Now, there's a column here. This column, you usually will not need it. So we may want to remove that column. And there's an additional argument we have to add it, which is row.names equal to false. So if we do that, we are going to get rid of the first column, which we don't need anyway, especially because it has no heading. Okay. So we can close this because we want to overwrite this file. So to remove that first column, we need to add this row.names equal to false argument to remove that column, and that should work fine. So if we go back and open that file, realize that the first column is gone now. We don't need it. So if we go into the web page, realize that there's the number of the countries in the first column, the number of Summer Olympic Games that they have attended, and then there's the Winter Olympic Games as well, and the number of games they played. Other tables have the number of medals, the league table of medals, if you like. So we can look at that one as well. Okay. Now, working with Excel files of different extensions, there's a very useful package that we use. It's called the Read Excel. So this is the package. Now, again, we realize that the function is read_Excel. So Excel of any extension will work. So you have CSV. Actually, it doesn't work with CSV. So we have XLS, SLS, SS. All the Excel extensions the read Excel can work with. So it gives you flexibility that when you have your Excel in any format, you don't necessarily have to take time and convert all of them to CSV. You can load them or import them into your workspace using the read Excel package. And the function is read_Excel. So we see how different that is from the CSV. So once it's Excel, okay, I will not mention. Let's look at how it comes out. So this argument is not needed. So we read it. Before we view it, I want us to look at the class. Has to be a data frame only. So it's a data frame basically, but it's also a table. So table_df is data frame. That makes it data frame. So this is XLS. You can also read another one with XLSX. And the class will be the same. One. So yeah, only one is loaded. Declare this thing. Only one is loaded. The class is the same, and we can view it as usual, the head and the tails and all of that. While I'm here, let me mention that there's a package called foreign. Let me put it here to remind you. So foreign, it helps in importing different packages, which you may use in the task. So we want to try importing data that is already in SPSS format. Now, SPSS format is .sav. So the HMIS package helps to do that. So once we have that package installed, the function spss.get. I remember the function for installing data, importing data file is read.dta, and we have some for SAS, even PDF. They are all, we can import files of different extensions as long as you are able to figure out the function from which package to use. So if you look at this is the data for the data we want to import is saved in .sav, that's an SPSS format. So it's a little bit big, so it will take a while to import. It's already done, and we can look at it as usual. So this is basically, this data is house prices. Let me put it in a view for you to see. View. Alex. So this is data for house prices along some towns in Johannesburg and the crime rates. So if you have a data like this, you can work with. Now we'll get back to trying to clean the data a little bit soon. Okay. So another one, which is a little bit bigger, also like that. Now we already captured writing the data into CSV or in a format that you want. So let's say you have a .sav file. You can open it in SPSS and export, which is a little bit uneasy because you cannot actually export. You have to copy them and paste them in Excel. But once you're able to to open them in R here, you can now save it as a CSV and you have it in Excel without going through the stress of copy and pasting on your desktop. And again, you can also remove the first column, which is not needed with the last argument. So realize that it is still writing the file into CSV, hasn't finished. So what you notice that it is writing, so it's taking time to put the data into the right rows and columns. So sometimes it takes a while.